Hello students, welcome to CMS online classes, and this video is for class 9 chapter number 3 atoms and molecules. As we all know, chemistry deals with the matters. Okay, so matters, we can define matters that anything that occupies space and has mass are called matters, and everything that is present in the earth are mostly made up of matters. Okay, so matters, actually we are talking about atoms. So atoms, in a simple way, we will write that atoms is the smallest particles. Smallest particle. Okay, so how we came to know that atom is the smallest particles? So let's have a look in a history. Okay, so in history, many Indian philosophers, that is what that was Maharishi Kanad, postulates that if we go on dividing matters, that means if we go on dividing matters, we shall get smaller and smaller particles, and ultimately a stage will come when we shall come across the smallest particles beyond which further division will not be possible. As for example, uh, if I tear this page, okay, so ultimately a stage will come when I can't tear this page, okay, and that is the smallest particles of this page. So similarly, in matters also, when we divide matters, a stage will come when that matter or that particles cannot be further divided, and the Indian philosophers named it as Parmanu. Okay, so in the same time, many Greek philosophers, is Democritus and Lysippus, suggested that they also suggested the same thing, but they named it a, instead of Parmanu, they named it atoms, meaning indivisible. That means the last stage that can be divided. And this was only the assumption. Assumption means the thinkings, but scientifically it was not proved or experimented. So in 18th century, many scientists, they try to find it out, and in the 18th century they experimented with various other elements, and Lavoisier, he put a two laws, important laws of chemical combination. Okay, means chemical combination means chemically combining two elements or two compounds. Okay, so in first experiments, law of conservation of mass, okay, that means law of conservation of mass states that mass can neither be created nor be destroyed. Okay, that means मास बनता भी नहीं है और ख़त्म भी नहीं होता in Hindi. Okay, we have an experiment here. Okay, so some gram of elements are taken, some gram of chemicals are taken, and at the last, when it is packed and chemically combined, we can see the same amount after the finished experiment. So as stated, it states that law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction. So in chemical reaction, whatever we reacted, the reactant product and the outcome product, okay, is the same when their mass are calculated. That was the first law. Second law, law of constant proportion. That means law of constant proportion means the proportion means what amount of chemicals is being used, and in the finished product same amount of chemical is found. Okay, so in a compound, we will take an example of water. The ratio of mass of hydrogen to the mass of oxygen is always 1.8. Okay, and 1.8 it is atomic mass. Atomic mass of hydrogen is 1 and oxygen is 8. So whenever the source of water, whatever the source of water, if it is 9 gram, okay, 9 gram of water, then 1 gram of hydrogen, and we will find that there is 1 gram of hydrogen and 8 gram of oxygen, as always, means correct proportion. Correct proportion means same. Okay, similarly in ammonia also, nitrogen and hydrogen are always present in ratio 14:3 by mass, and this 14:3 is the atomic number. And atomic number has been mentioned in a periodic table. Okay, so it states that in a chemical substance the elements are always present in definite proportion by mass. That means the proportion is fixed. Okay, then according to Dalton atomic theory, all matters, whether in elements, a compounds or a mixture is composed of a small particles called atoms. Okay, means previously before or at around 500 BC, they only postulated, means they only assumes, but after the 18th century in an experiment, when they experiment, they also found the same thing. Okay, so Dalton atomic theory, so what it states, okay, all matters is made up of very tiny particles called atoms which participate in chemical reactions. Number 1. Number 2, atoms are indivisible particles which cannot be created or destroyed in a chemical reaction, means law of conservation of mass. Atoms of a given elements are identical in mass and chemical properties, means they don't change their identity. Okay, by looking we can see different chemicals, but when it is chemically tested, they don't change the chemical properties. So atoms of different elements have different masses and chemical properties. Okay, atoms combine in the ratio of small whole numbers to form compounds, means in a ratio of whole numbers means 1 2, okay, 1:2 or 2:3. Okay, these are whole numbers. The last one, the relative numbers and kinds of atoms are constant in a given compound. Okay, means law of chemical constant proportion. Sorry. Okay, so this was all about Dalton's atomic theory. Okay, now let's move towards atom. So there is a question, what is an atom? So as already discussed, it is the smallest unit of a elements or a matter. Okay, so there is an example that here we observe mason building a wall. For this wall, a room and then a collection of rooms is form a building. That means, as for example, in a building, okay, in a building we have many flats, then in a flat we have rooms, and that room is divided by bricks. So we can see in a building that brick is the smallest unit of a building. So similarly, atoms is the smallest unit of a matter or an element. Okay, so how big is our atom? As we already discussed that it is the smallest unit, okay, but also it has a size. So how big? That means what? So millions atoms, when it is stacked or when it is mixed, we only find a small bit of that means it can't be seen with naked eye. Okay, it can be seen. As for example, atoms of hydrogen is 10 into minus 10 to the power. Okay, that means imagine an apple. If apple is 10 of its size, okay, that means 10 of its size, that means atom of hydrogen is 10 into 10 into 10 into 10 times, that means not in plus, in minus. Okay, so you can imagine how small an atom can be. Okay, now we imagine that how small is an atom. So previously on those time, due to lack of technology, the size of the exact size of the atom cannot be determined. But nowadays, through modern techniques, we can have a correct image and size of an atom. Okay, so what are the modern symbols of atoms of different elements? There are many elements, as we all know. Okay, we have iron, we have silver, we have aluminum, copper, gold. Okay, so they have a symbol. So Dalton, he was a great scientist. So at his time, he just made a symbol of different elements. Okay, like hydrogen, one circle with a dot, carbon circle with some shades, oxygen circle, iron circle, and in the inner is I, sulfur, a plus sign in a circle, phosphorus, a sign of three three stacks. Okay, copper inside C. So he just made these symbols, okay, at that time. And later on, to make it a standardized version, okay, IUPAC, that means International Union of Pure and Applied Chemistry. It is an international scientific organization which approves names of elements, symbols and its units. Means it's not that whosoever scientist, they just write I have found one element, that name is XYZ. Okay, YZ, the element XYZ. Okay, so if that is done, he can't put it in a study. First, he have to register, or he or she have to register these elements with IUPAC. Then IUPAC will not experiment, investigate that is this the correct one. Okay, what these scientists have put forward, is it correct or not? Okay, then this organization gives the name. Okay, so later on the elements name and symbols was done according to the alphabets. Okay, so for hydrogen they have given H, for aluminum Al, cobalt Co. Okay, similarly we have many elements that can be seen here: argon Ar, boron Ba, calcium Ca. But here you will find that in some other elements their name is not mentioned. As for example, sodium. For sodium we have Na. But if you think according to IUPAC, if you think, then sodium must be SO. But it's not that. Why? Because this name has been given according to the Latin, Greek or German name. Okay, sodium is not a Latin, Greek or German name, it is a common name. Okay, so symbols of elements are found from a first letter of the name and a letter appearing later in the name. Example, chlorine, Cl, zinc. Other symbols have been taken from the names of the elements in Latin, Greek or German. For example, symbol of iron is Fe. Okay, so from Latin name ferrum. Actually iron Latin name is ferrum. Similarly sodium, what I told you, sodium Latin name is natrium. Okay, so don't get confused that IUPAC has only mentioned the first letter of a element to be named as an to be symbolized as an element. Okay, so now let's come to atomic mass. What do you mean by atomic mass? Okay. So different elements have different atomic mass, and in some cases it is easier to find atomic mass, but mostly this atomic mass cannot be identified in a individual. Okay. So by combination the atomic mass can be formed. So if there is a, if I mix, suppose as for example, if I mix I'll just make an example. Okay, if I mix 200 ml of water in 800 ml milk. Okay, 800 ml milk. So the total amount of that liquid is how much? Total amount of liquid is how much? 1 liter. Okay, that means 1000 ml. So the proportion is how much? 2:8. The proportion is 2:8. So we can say that 200 ml of water, 2 ml of water and 8 ml of milk is mixed to produce 10 ml of a liquid. Okay, 10 ml of liquid. That means it is its atomic mass. Okay, similarly, let's take an experiment of an compound. Okay, compound of carbon monoxide found by carbon and oxygen. Okay, so it was observed experimentally that 3 gram of carbon combines with 4 gram of oxygen in the ratio 3:4. In the ratio 3:4. Okay, so and that must have a unit also. Okay, as for example, for liquid we have milliliter. Okay, we have milliliter. For mass we have grams. Okay, and for distance we have kilometers or meters. Okay, similarly these compounds also have some, must be given some units. That means atomic mass must be given some units. Okay, and that unit is written as U. Okay, small u. Okay, now as we talked about atomic mass, so there is a table. Okay, here atomic mass of few elements have been written. For example, for hydrogen it is 1, for carbon it is 12, nitrogen 14, oxygen 16. Similarly, sodium, magnesium has been given here. Okay, and by this atomic mass only this element has been placed in a periodic table. Okay, I'll show you the periodic table in my next class. Okay, then how do atoms exist? Okay, how do it exist? So atoms of most elements are not able to exist independently. Okay, because atoms is the very smallest unit, and it is not possible for an atom to exist independently. So atoms form molecules and ions. Okay, so these molecules or ions aggregate in large numbers to form matters that we can feel, touch or see. Okay, that means oxygen and what? Hydrogen and oxygen. Hydrogen plus oxygen. Okay, so this is an element. Hydrogen we can't see, we can't feel. Oxygen we can't see, we can't feel. Okay, forms what? Means this is element, and this is molecules. Okay, compounds are molecules. So water you can see also, water you can feel also. Okay, so this was all about the first part of chapter number 3, atoms and molecules, and in our next class we will talk about molecules. Thank you.